This will be for the con exercise, rational functions, zeros, asymptotes, and undefined points. All right, I believe these options will be the same for all the problems. I'm not sure. But at any rate, in order for you to get one of the zeros, or the x-intercepts, that is going to occur when the numerator equals 0. Okay, and for the vertical asymptote, that is going to occur when the denominator equals 0. Because denominators cannot equal 0, the graph will never reach that dashed line or that asymptote. Okay, and finally, for removable discontinuity, that's when both the numerator and the denominator equal 0. Okay, you should have a term, likely a binomial, that will cancel on the top and bottom, numerator and denominator. All right, so for the first step, I am going to set the numerator equal to 0. All right, so x squared minus 2x minus 24 equals 0. All right, in order to solve this, we have to factor or use quadratic formula. Let's try to factor. See if you can find two numbers that multiply to negative 24 and add to negative 2. Well, if we write out the factors for negative 24, we have 6 times negative 4. That adds to positive 2. And we have negative 6 times positive 4. That adds to negative 2. So we're going to use these two factors. And to rewrite this in the form of a binomial, we start with x and x. Okay, because x times x is x squared, and we add in the negative 6 and the positive 4. All right, you really should know how to factor first before you do this exercise. So if you don't know that, find the factoring exercise and do that first. Anyhow, anything times 0 equals 0. So this can equal 0. And x plus 4 can also equal 0. All right, so here we have x equals 6. If I just do plus 6 on both sides. And here, if we do minus 4 on both sides, we have x equals negative 4. All right, and now I am going to do the denominator. All right, so this here was the numerator. And over here, I'm going to set the denominator equal to 0. All right, so x squared plus 10x plus 24. All right, so two numbers that multiply to 24 and add to 10. If we again write out the factors for positive 24, we have 6 times 4, and those two numbers add to 10. So rewriting this as a binomial, we start with x and x because x times x is x squared, and we use positive 6 and positive 4. All right, you can set these equal to 0 individually. Most of you can do this in your head. X plus 6 equals 0. And x plus 4 equals 0. All right, minus 6 on both sides, you get negative 6. Minus 4 on both sides, you get negative 4. All right. Now, we said if the 0 occurs in both the numerator and denominator, that it is a removable discontinuity. Okay, so that is the negative 4. Since it occurred twice, that is an RD, removable discontinuity. Okay, this one here, when the numerator is 0, that's just a 0. That's just a regular 0. So I'll just put a Z there. And the negative 6 is when the denominator was 0. That's a vertical asymptote. Okay, and just so for your information, the reason the negative 4 is a removable discontinuity, if you wrote the numerator as these two binomials and you wrote the denominator as these two binomials, the x plus 4 divided by x plus 4 would cancel. All right, so 6 is the 0, negative 6 is the vertical asymptote, and negative 4 is the removable discontinuity. All right, so 6 was the 0, negative 6 was the vertical asymptote, and negative 4 was the removable discontinuity. All right, so once again, we have our rational function. Okay, by the way, a rational function is just basically one polynomial divided by another. Anyhow, we'll start with the numerator equal to 0. Okay, so that's x squared plus 4x minus 32. And that equals 0. All right, and on the other side, denominator equals 0, x squared minus 8x plus 16. All right, so factoring the numerator first, let's write out the factors for negative 32. We want to look for a pair that adds to 4. Negative 32 is the same as negative 16 times 2. And I'll write them over here. We can also do negative 8 times 4. That adds up to negative 4. And if we did positive 8 times negative 4, that multiplies to 32. And when you add them, it adds to positive 4. So that's 8 and negative 4. All right, we're going to write this as two binomials equals 0. X squared, so we start with x times x, and we add in plus 8 minus 4. All right, anything times 0 is 0. Either of these can equal 0. If x plus 8 equals 0, x is going to be negative 8. If x minus 4 equals 0, x is going to be positive 4. All right, you can do that in your head. You know 4 minus 4 is 0, and you know negative 8 plus 8 will equal 0. All right, factoring right here, writing out the factors of 16, we want 2 that multiply to 16 and add to negative 8. All right, 16 is the same as negative 4 times negative 4. Okay, and if you add these two, they add to negative 8. So writing this trinomial as two binomials equals 0, we have x squared. You start with x and x. Okay, and you have negative 4 and negative 4. All right, so it's the same binomial each time. Now this part, I actually fell into the trap here. You actually have to set both of these equal to 0. I know it's the same thing, but if you did x minus 4 equals 0, you would get x equals 4. And of course, if you took the other one and did x minus 4 equals 0, you would again get x equals 4. So here's the thing. If we had this numerator written as this binomial, these two binomials, and this denominator written as these two binomials, x minus 4 divided by x minus 4 would cancel. Okay, so you can cancel this and this. However, this denominator still has another 4 as a 0. So this is going to be a vertical asymptote. And this right here is going to be a 0. Okay, if we couldn't if we didn't have another 4 here, if we scratch off the 4 and the 4 and we didn't have this, this 4 would have been a removable discontinuity. Okay, but because we had another 4 that we couldn't cancel, another x minus 4 that we couldn't cancel, this is actually going to be a vertical asymptote. Okay, and this is going to be a 0. So I made that mistake initially. -8 is the 0 and 4 is the vertical asymptote. All right, -8 is the 0 and 4 is the vertical asymptote. All right, so I got it wrong at first because I selected removable discontinuity. But you have to do both zeros in the denominator, and only one of them canceled, one of them was left over. All right, last one, numerator equals 0. So if we did x plus 3 equals 0, basically you get x equals -3. All right, so that's pretty simple. And then the denominator, x squared plus 2x minus 3. That equals 0. All right, we're going to do 2 binomials equal to 0. Since we have x squared, it's going to be x times x. And for -3, what factors add to +2? Well, how about 3 times -1? That equals -3, and when you add them, they're going to equal +2. So we're going to do +3 minus 1. All right, right here, x is -3. And right here, x is +1. Because we just set each one of these equal to 0. Now, if you can cancel -3 and -3, that means that one was your removable discontinuity. And when the denominator equals 0, that is your vertical asymptote. Okay, so that's basically it. -3 and +1. -3 was your 0. I'm sorry, -3 was removable, and +1 was your vertical asymptote because the -3 canceled.